Hi guys, welcome back to Chapter 8 for Algebra. We're on Section 8.8, the difference of squares. So we're going to go ahead and factor these binomials, but they are the difference of perfect squares. So difference means it's got a minus. Squares means it's a perfect square. So something times itself will give you that number. We can make this easy or we can make it a little lengthier. So let's do a quick, let's just factor this first one right here, x squared minus 25. So we can use a product sum table, we can use the square method, we can guess and check. I'm going to use the square method for this one in particular. And since I don't have any b term, I'm going to go ahead and say it's 0x in the middle. It seems logical, right? So I know that I want these two diagonals to add up to 0x. I know that I want this to be an x squared, and I know that this should be a negative 25. So two numbers that multiply to give you an x squared. Easy peasy, x times x. Two numbers that multiply to give you a negative 25. 5 and 5 seem like the easiest ones. One's a positive, one's a negative, right? Which means when I go into my diagonals, x times 5 for this top right would be a 5x. And negative 5 times x for this bottom left would be a negative 5x. So those guys add up to a 0x. So my two factors will be an x plus 5 in one parenthesis, and then over here an x minus 5 in the other. If you want to use a product sum table, you're more than welcome to. If you want to use guess and check, you could certainly do that. But anyway it goes, we get ourselves an x plus 5 and an x minus 5. So what is the pattern? The pattern is both a and c, the x squared and the 25, if I'm just going to look at the number itself, are perfect squares. And there is a minus in between. If you've got both of the terms of the binomial are perfect squares, and and there's a subtract in the middle because it's the difference, we can make this really simple, short and sweet, go right from the problem to parentheses. So some value, a squared minus b squared, is going to be equal to, when we factor in the two parentheses, a plus b and a minus b. So if we want to think of this in terms of numbers, a problem we could actually do, I'm going to do 4x squared minus, I don't know, 81. Oh. So the first thing I want to look at, think about the pattern, is 4x squared a perfect square? What's the square root of 4x squared? What times itself will give you 4x squared? 2x times 2x, right? Is 81 a perfect square? Of course it is. What's the square root of 81? 9. So what we can do, since we've got both of those terms are perfect squares, and we've got the minus in between, we can set ourselves up a really simple answer of two factors. The square roots of both of them, one with a plus, one with a minus. So I'll do 2x plus 9 and 2x minus 9. So the 2x and the 9 came from square rooting both parts. No problem, right? And if you wrote them in the opposite order, 2x minus 9 first and 2x plus 9 first, or second, you'd still be right. So let's do some quick steps. First thing that you should do is factor out a GCF if at all possible. Once you notice they're perfect squares, or perhaps they won't be perfect squares until you take out a GCF. Like if I had a 2x squared minus 32. Well, I notice right away that 2 goes into 2x squared and 2 goes into 32. So if I factor out a 2, I'd be left with an x squared minus 16. Now, inside my parentheses, x squared is a perfect square, and so is 16. Determine the square root of both a and c. Square root of x squared is x. Square root of 16 would be 4. You might just do that mentally. You don't have to write it. Rewrite in factored form or parentheses. So if I'm thinking about that x squared minus 16, I would have an x plus 4, an x minus 4, and I'm not sure if I mentioned it, but this GCF, that 2, just stays sitting out in the front of those parentheses. Check to see if your factors can be factored again. Can I factor x plus 4? I automatically know since the exponent on the x is a 1, I cannot. Same with the x minus 4. The only time I can really factor is if I've got myself a second power or if I didn't take out a GCF at the beginning. And if you have to, if we've got 4 terms, group them up in pairs and then do our usual thing, do 2 separate GCF problems. So let's do a quick number 1. X squared minus 36 over 49. Messy, ugly looking problem. People see fractions. You want to turn them into decimals. Don't do it. You might be tempted. Notice there's a minus in the middle. And if I look at x squared, is that a perfect square? It is, right? If I look at just the numerator, is 36 a perfect square? It is, right? If I look at just the denominator, 49, is that a perfect square? It certainly is. Everything's a perfect square, minus in the middle, so we can go right to our 2 sets of parentheses. I'm going to use my x plus 6 over 7, x minus 6 over 7. Excuse my coughing. And I've got myself factors. Number 3 is a trick problem. Do you see what's wrong with number 3? Can you factor an x squared plus 25? You cannot factor because it's got a plus. I'm going to try to trick you. Don't fall for my evil tricks. Number 4, you couldn't factor with perfect squares until you take out a GCF of 3x. Give it a shot. I think we'll do that one in class. Same with number 5. Let's talk about solving equations before I die coughing. First, make sure that all terms are on one side of the equation. What's the problem with the problem? It's got to be equal to 0. Then factor out a GCF, just like the first step on the last thing we wrote out. Number 1 thing to look for is a greatest common factor. You can still do the problem, but the numbers will be bigger. Sometimes you can't. Factor it using whatever means necessary. Squares, shortcuts, guess and check, product sum tables. Set each factor or parentheses equal to 0. Write your answer in set notation. And if you choose, you can check your solutions. So let's do a biggie. Well, let's do a littlie. Let's do an x squared minus 49. First of all, does anybody catch a shortcut here? This is really nice, right? I notice there's a minus in the middle. I notice that x squared is a perfect square. What is its square root? 49's perfect square. What is its square root? So I can factor. This thing is equal to 0, which was really important. I forgot to point that out. So I'm going to keep it equal to 0. So I know that I've got an x and a 7. What are the signs in this difference of perfect squares? One's a minus, one's a plus, because when we do last times last, that gives us a negative 49. Now that I've got that, the worst is over. I'm going to set each factor or parentheses equal to 0. And I'm going to go ahead and solve these guys. This one I'm going to add 7. This one I'm going to minus 7. So I get an answer of x equals 7. and -7. Sometimes I get real lazy and I just put a positive and a -7 for my two answers. And I'm solved. Let's do one last problem. Let's do number 3, because this one has several issues. First of all, is it equal to 0? What is the problem with this problem? We have to get the 3y over to the other side. That's where we're going to subtract it, because if I subtract it, that crosses out and I've just got 0 left. And then here, I've got a 48y cubed minus 3y. According to those steps we wrote down, the first thing that you do after you make it equal to 0 is look for a GCF. I noticed that my y has an odd exponents, 3 and 1. I cannot factor unless I take care of that issue. I need an even number. So I know that y will be one part of my GCF. I think also a 3. So think factoring. 3y times what will give us a 48y to the third. If I do 48 divided by 3, I get 16. And then I need 2 more y's. 3y times what will give me a -3y? That would be a -1. If I just look at that red or highlighted part, now I'm going to think, can I factor this? Since we're in the difference of perfect squares section, I'm going to look first to see if it's a difference of perfect squares. I also look there because it's a binomial. So is 16y to the second power a perfect square? What times itself will give you 16y to the second? Is 1, just looking at the number, a perfect square? Well, of course it is, right? 1 times 1 gives us a 1. So that means, that I can go, if I just look at the red highlighted part, I can make that a 4y plus 1 and a 4y minus 1. I'm just going to bring that 3y straight down, stick it on the front. Now again, your big clue is it's equal to 0. That means I want to know what y could be equal to. I've got 3 y's in this problem, which means I'm going to have 3 answers. So I'm going to take each part, each factor, and set it equal to 0. And now hit pause, solve those. If I want to solve this one, I divide by 3, and I still have a 0. If I want to solve this one, I subtract 1 and divide by 4, and I get a -1/4. If I want to solve this one, I add 1 and divide by 4, so I get a +1/4. So my solution set for this problem is going to be 0, +1/4, and -1/4. I could go back up to my original problem. I could put a 0 in, make sure that I get the true statement. I could put a +1/4 in and a -1/4. So lots of work here. The thing is you've got to factor or make sure you've got parentheses before you can make them equal to 0. If I gave you a problem that already had parentheses, you've already got the whole first half of the problem done, so don't do extra work. So here's what I would like to know. What's one important thing to remember when factoring differences of perfect squares? And solve that. First, make sure you factor, and the first thing I would say is, what's the problem with this problem? Make sure you get it so it's equal to 0 before you do anything else. Then it looks to me like all the parts are perfect squares, so you'll have 1 parenthesis with a plus, 1 parenthesis with a minus. You'll have 2 answers. They will both be fractions. That's it for section 8.8. Have a good day. We'll see you next time.